Hi, this video is about plotting data in Matlab. We're going to start off with the basics of plotting in Matlab, and after that we're going to look at how do we generate data into Matlab and use this data in the plots. And then we're going to look at basic 2D plots, the line, scatter, and bar plots, and some of the plot features of the 2D plots as well as other plots. And finally we're going to look briefly at the 3D plots in Matlab. So to plot, we would need to have data in the workspace first, because Matlab does not understand equations or functions. What I mean by functions are equations, and it can only plot the arrays of numbers or the numbers in the workspace. So we're going to start off with defining a few sets of data which represent several equations, and then we're going to plot those data. So first we are going to generate a value t from 0 with an increment of 0.01 until 2. Suppress the output. I've created my t. And then the first equation. So let's name the first equation as a equals to t squared. So notice that I used the element by element exponentiation because we are expecting t to be, each element of t to be the power of 2, instead of performing a matrix to matrix calculation or dot product between equal size matrices. So suppress the output, and I generated my A equation. So we can start to plot these two values just by typing the command plot, and then the first argument is the x-axis, which is t, and then the second argument is the y-axis, which is a here. Press enter, and a window will pop up. Will show you the graph of the equation a equals to t to the power of 2. I'm going to close this now and then plot a few more graphs. The second example is b equals to sine 2 times pi times t, and then c equals to exponent negative 10 times t, and then d equals to cosine 4 times pi times t. Suppress the output, and e finally t to the power of, no, to the 2 times t to the power of 3 minus 4 times t to the power of 2, and finally plus t at the end. Now I have my 5 equations, and we'll see how we can plot these 5 equations. Let's start by just plotting. Just now I showed you that we need to plot the x-axis and the y-axis so that you'll be able to come up with a x versus y graph. But then you can also plot the y, or a single array, just like so. Say a. It would give us the same trend as the y versus x or t versus a plot just now, just that now since we only plot one variable, which is a, it automatically assigns the x-axis to be of the index, to be from 0 to the number of variables there are in the t array. So that's why here from 0 to 250 it's not exactly as if you were to plot it y versus t or a versus t. So if I were to plot t a, notice that the x-axis now is from 0 to 2 and then from 0 to 4 for the t. So now let's try plotting all of them at once. t a. Then if you like to add in more figures in the same, add more graphs in the same figure, then we just continue at the back of the first set of values. So the first plot is t versus a, and then the second plot again is the same x-axis, t versus b, t versus c, t versus d, t versus and t versus e. And there you have all of the 5 equations plotted in the same plot. So let's say we like to plot not two plots, but we don't want to put them in the same figure window. We can try the obvious, plot T versus A first, and then a window will pop up, and then we plot the second one. What will happen is that the first plot would be overwritten by the second plot. So if you like to plot in the same window, aside from just what we did just now, we can use this statement called hold on. So plot TA first, check whether the plot is there, yep, and then type hold on, and then the second plot. By using the hold on statement, you'll be able to plot two figures or more than two figures into the same plot. You can also invoke this figure window. Let me just close this first by typing in the statement figure, and then plot TA, and the plot TA would be plotted on top onto this figure window. Now we're going to look at how can we customize the plot. The default color for a plot is blue, but if we like to change it to another color, like say red, we just add in more arguments at the end after the y-axis or after the second argument. So here, plot TA, and let's say I like to color it red instead of blue, then I put an apostrophe and then the symbol R, which stands for red in Matlab, and then the close apostrophe, and press enter, and you have a figure or a line plotted in red. What if black? Then it will be plot TA K, it's black, green, G, cyan, not sure whether I'm pronouncing it correctly, cyan or cyan. So basically it's just light blue green, say TD. For cyan it will be C, and then I like to have markers onto the plot. If you notice just now, all the plots that we've plotted so far, they're all straight lines, but what if we like to add markers? Then we just add in more arguments after the color argument here. So let's say we like to plot, you would like the figure or the graph to be cyan and with the marker X. So we type in CX, close, and you see that it's the marker has changed to the cyan color and it's X. What if we like to plot a line with the marker O but colored magenta? Then we'll just type plot TE, dash line will be dash dash or double negative, OM, close apostrophe, and there. So this is magenta with O's as the marker, and maybe you don't get to see the dash here, but I just need to zoom in just any area so that you can see there, the dashed line. We can also modify the thickness of the line, the marker edge, and the fill color and marker size. So I'm going to give you an example here. So let's say I'd like to plot TE, dash line with the marker O, colored magenta, so dash dash apostrophe, dash dash OM, close. And then I need to say to Matlab that I would like the line width to be 3. So to let Matlab know that I would like to refer to the line width argument, then I just set this argument, line width, close, and then right after this, then I specify how thick I want the line to be. So here in this case, I like it to be 3, close, and then the next let's say we like to change the color of the marker edge. So we have the marker and the edge of the marker. What if we like to change it to another color aside from the same color as the what we said here, magenta? So we do that by writing in the argument called marker edge color, close apostrophe, and then we like it to be black. So okay. And now I like to change the color inside the marker. So we use this argument, marker face color, close apostrophe. And then we, after the argument, then we give what we would like it to be. So let's say I like it to be yellow, and I just type in Y. And then I like the marker to be a bit bigger than the default size, so I use this argument called marker size, close apostrophe, and then let's say I like to be at size 9. And close parentheses, and there you have it. You see the plot of TE dash line. Let me zoom in so that you could see. So the dashed line is the color magenta. The line width of this dashed line is 3. The marker edge color, this marker of O, the color of the edges of this marker is black. The color inside the marker is yellow, and the size of this marker O is 9. Okay, now how do we add labels, title, and legend into this plot, or into a plot in Matlab? Let me close this window first. To do this, because it's a multi-command steps to create a plot with the legend, then I'm gonna do that in the script. So I'm just gonna click on this new script, and I'm gonna write those commands to plot, and also to add in the title, customize the label, the x-axis and the y-axis, and also add in a legend. So let's start off with the plot. So let's plot TA and TB. And I like the TB to be in red. And then TC. That means 3 plots. But this TC, I like it to be dashed line with the marker O and colored magenta. Close apostrophe, and close the parenthesis and suppress the output. And after running this, I will see the plot, but it's not done yet. I need to add in the title, the X label, and also the X label, Y label, and the legend. So to add in the title to this plot, I just need to use this function title right after the plot. So I'm just going to call it random plots. Suppress the output. The suppress the output is optional because in the end, this command does not show the output in the command window. So it's optional for you to have it to suppress the output or not to suppress the output. Okay, now let's add in the x-axis label. Using the function x label, I'm going to call this time, capital T, in the parenthesis milliseconds, and then close the apostrophe, and then close the parenthesis to end the command. And then the y-axis, you guessed it, the label for the y-axis is y label. The command for the y label axis is y label. So that will be, let's say, ft. Oops. Okay. Hope I forgot to put the closing apostrophe. And then now we're going to add the legend. So we add the legend by using this function called legend. And let's just call it the generic function 1 for the first function, or the first equation, function 2 for the second function, and function 3 for the last one. Now to run all of this at once, I just need to click on this to run, but then it's going to prompt me to save it. So let me click on run, and then saving it as random plots. Save. It ran all of it at once, and then we're gonna have we can see our 3 functions. The first function This is the second function, and the third function with the legend. Notice the y-axis label and the x-axis label, and also the title. Okay, so what if we would like to modify the ranges of the axes? Let me just run this again to show it to you. If you notice, what we've done so far, we have not specified the ranges of the axes. Matlab automatically decide the ranges of the axes for you. Most of the time it does a good job, but let's say you would like your own or a customized axis range, then you can do that using the command axis. So I'm gonna just delete this, and then we're gonna start off with another example. So in this example, I'm gonna invoke the figure first by using this figure command. What I'll do is just open up a blank window, figure window, and then the plot, TA. I like to color it red, and then add in the axis command. So in the axis command, what we need to give is the ranges of the x-axis and the y-axis. So let's say I would like it to be from the minimum -2 in the x-axis to a maximum of +2. So I need to put that in an array. So I use a square bracket, open square bracket first, and then this is the minimum for the x-axis and the maximum for the x-axis, and then space, and now it's the y-axis. So the minimum again, -2, let's say, to the maximum 2, close bracket, close the parentheses, suppress the output, and then if we run this, you see that we've told Matlab to, even though the plot ideal range would be from 0 to, let's say, 1.5, but then we explicitly told Matlab to set the x-axis to be from -2 to 2 and the y-axis from -2 to 2, which makes this plot seem to be hanging in the middle of the plot. So what this example demonstrates is that you'll be able to customize many things in your plot by using commands that I cannot possibly teach all of it here in this brief tutorial. Okay, so how about subplots? How can we create multi-panel plots? Let me just delete this. Let's say we like to create a 2x2 panel, which is a total of 4 plots in a single plot window. So we start off with figure to open up the plot window, and then the first plot. So we use this subplot function, and then the first argument will be the number of rows of this multi-panel plot. We like it to be 2x2, so the row should be 2, and the column should be 2. And the first plot, the number after this, the column 2, is the sequence of plot. So you'll start off from the top left to the top right, and then to the bottom left and to the bottom right. So if I write here 1, then it will plot the first plot, the top left panel of this multi-panel plot. And then plot. Now we've finished with the first plot in the 1, 1 position in that multi-panel plot. Now the second plot, we need to use the function subplot again, 2, 2, and now in the position 2, plot TB, and then subplot again. I hope you can see a pattern by now. And then the last plot in the 4th position. And that's it. We're going to see a 2x2 multi-panel plot, with this being the first plot, the top left, the top right, the bottom left, and the bottom right. Click on Run, and there you have it. Multi-panel plots in Matlab. Now, how can we plot bar graphs in Matlab? we can plot bar graphs by using the function bar. Let me clear this first. I will specify a new set of values to plot this bar graph. Let's say T3 is the x-axis from 0 with the increment of 1 to 25. Express the output, and then the y-axis of the bar graph, square root of T3. Express the output, and then to plot it is just bar. The first argument is the x-axis, which is T3, and then the second argument is the y-axis, which is F. Click on run, and you get to see your bar plot or bar graph. Now notice that since you did not specify the width of each bar, then Matlab assumes that you would like it to be with each bar to have a width of 1. The default is 1 for this function. Now, how can we plot histogram, cousin of the bar plot? Clear this up first. To plot a histogram, we just use this function called his. I'm going to use this variable b as a sample, and then 10, the second argument, is the number of bins that I would like it to plot the histogram, because histogram is a plot that classifies the data into different bins. So in this case, I would like Matlab to look into B and then classify the data into 10 even bins and place the data into 10 different groups. So let's see how that looks like. So that's the histogram for B with 10 groups or 10 bins. Okay, so now let's look into 3D plots. But what I'm going to cover here is the basics or just a few functions in Matlab that you can use to plot plots in 3D. There is the mesh, the surf, and the contour function. And before we can plot 3D plots, we have to generate three-dimensional data. So far, what we've seen are two-dimensional data, x and y. But for 3D plots, you would need to generate x, y, and z values. In Matlab, it is built-in 3D dataset for us to test 3D plots. So one of it is the peaks dataset. So to access this dataset, we just type in x, y, and z for the x, y, and z axis equals to the function peaks, and we would like it to have 25 values of these x, y, and z values. If I click on run, I did not suppress the output, that's why the values are shown in the command window. So here we see that the x, y, and z axis is generated, and it's a square matrix for x. It's not a vector or column matrix like what we've generated so far. Y is also a square matrix, and z is also a square matrix. So you can't simply just use 2D data to plot 3D plots. You would have to first generate the x-axis in a square matrix and the y-axis in a square matrix, and then even the z-axis to be in a square matrix before you can plot these 3D plots. Another data set we can create here. So x equals to minus 10 to 10. So what happens is you're going to create 1 to 21, and then y equals to negative 10 to 10, and then create the z-axis, x to the power of 2 transpose times y to the power of 2. So just now we used the function in Matlab to generate our x, y, and z values. But here we created our own x, y, and z values. But notice here that the x-axis is still a row vector and y is still a row vector. But x here is a square matrix because it's basically x to the power of 2 and then multiply dot product with the y to the power of 2, which would create a square matrix. And you can also plot 3D plots using this x, y, and z values, even though the x is not a square matrix and the y is not a square matrix. Because Matlab knows that there are even amounts of numbers for x from -10 to 10, and there's even number of values for y, so it extrapolates for you to create the square matrix when you invoke the 3D plot function. So let's get to the good stuff. It says mesh is a 3D plot function. The first argument, you guessed it, is the x-axis, second is the y, and the third is the z-axis, z values. Press enter, and that's our 3D plot there. If we use this peaks, let's say if I run this and then replace the x, y, and z values and use the same function mesh x, y, and z. Oops, it's behind the window. Then this is the 3D plot of the x, y, and z using the peaks function to generate the x, y, and z values. So instead of mesh, you can also use surf. This is what surf looks like. It has the same general look, but now instead of empty cells, it just filled it with color. And if you like to show a contour below this plot, you can use this contour function. Sorry, it's just to show the contour from the top, because if you remember the plot just now, if you see it from the top, and this is the contour that you're gonna observe. Contour is a 3D plot with a view from the top. If you like to see the contour below, then you just use a function like, for example, mesh, but then add a c at the back. There you see the contour below. Same goes for surf, c. There's also this plot 3 function to plot 3D plots. Let's test it and see what we'll get. So that's what it looks like. And the specifications, the customization of 3D plots are the same as the 2D plots. So anything that you learn in the 2D plots should be able to be applied to the 3D plots. Like the X label, Y label, title, legend, and so on. You should be able to use those same functions for the 3D plots. You can also, since a 3D plot has depth into the plot, then if you like to view the plot at a certain direction, then you can use the view function. Let me first plot this again. Okay, by default, Matlab would use this view, but to change this view, you can use that view function. View. The first argument is the azimuth, or the rotation around the x-axis, say 0. And the second argument is the elevation, or the rotation around the xy plane. That means whether you look up or look down. So let's say 0, 2. See what happens to the surf view just now. It's from the side. What if we change the azimuth to 90? That means we look from the other side, but still directly 0 degrees into the side of the plot for the elevation. This is from the other side of the plot. And then we can also add color bars. Like here, we don't know what this yellow mean, what does this blue, dark blue mean. So we can add a color bar as a legend to the colors. It's basically automated. You set the lowest value as the coolest color and the highest value as the hottest color. But the only thing that we'll change here right now is whether we like it to be a color bar in the vertical direction or in the horizontal direction. So if I type vert like this, then you have a vertical color bar at the side. Lowest -6, the highest is about maybe 7. And if you like it to be horizontal, just type horiz, and then you have the horizontal there. So these functions like view and color bar, you can only use these functions after a plot. But if there's no plot and you try to use those, and an error will come up. Let's see whether it does. So color bar again, say horiz without, notice that, remember that I just closed the window just now. Yeah, it will still come up, but then there's no plot there. And it defaults from 0 to 1. Not much useful anyway. We can also change the range of colors in the plot, just like how we changed the x-axis and y-axis in the 2D plot just now. So to do that, let me just type in plot against surf. Okay, and use this as an example. Okay, c-axis. To change the color of the axis to a different minimum than the default set by Matlab. So say the minimum is -2, the maximum is 2. If you remember just now, the minimum was -6 and the maximum was +7 or +6. Press enter and see what happened to the plot. So here it just shows the color between -2 and 2. And if I put in the color bar, it's from -2 to 2 instead of from -6 to +6. And the last function that I like to cover for the 3D plot is the color map. Here is the default color map, but there's a few color maps like HSV, Jet, Autumn, VGA, and Summer. So let's just go through them sequentially and see what they look like. Let's put it here on side by side. So let's say color map, HSV. This is what HSV color map looks like. Color map, Jet. Color map, Autumn. Color map, VGA. And finally, color map, Summer. You can bet that there are numerous color maps, palettes of color that you can use, but this is just some of the more common ones, and some people will just use the simplest one, the default one, if it serves his or her purpose. But if you like to add more variety to the colors of your plot, then you could consider looking at the other color palettes. So that is it for this tutorial on the basics of plotting in Matlab. If you find this video useful, then consider liking it. If you have any questions, you can write in the comment section below. And that's it for this video for now, and I'll see you in the next one. Bye.